Okay, so our last section of this chapter is called changing of variables in multiple integrals. And like we were doing with a lot of the other stuff, this is kind of, it's not intuitive. You're not going to be able to think of your transformations as easily, but it's applied from like my first dimensional integration to now doing this with multiple integrals. Okay, so we started back here doing this when we were just doing one-dimensional calculus with f of x. We would do a substitution using u equals. So we'd take something that was, a little bit more complicated, and if we changed it into a different variable, we were able to solve that integral a lot easier. The goal is going to be the same thing for this section. Maybe it's a region that's more complicated. Maybe the integration is too hard. But if we can transform it into some different variables, then we're going to be able to make an easier problem for us to solve. We've actually already done this. We've done this chapter with cylindrical and spherical coordinates. So you've already done this, and the big piece that we figured out is once we made that transformation, we knew that we had to use circles or we had to use cylinders. Then it was adding that extra piece on there, the r, or the rho squared sine of phi, which we haven't done much with, I know, but like we've already kind of done this. This is just going very general. So what we're going to do is we're going to get some transformation that takes it from the xy plane and converts it into the uv plane, or vice versa. Those doesn't really matter to me. I'm taking a region that's a little bit funky and I'm going to convert it into a region that makes a little bit more sense. So today we only have about 15 minutes or 20 minutes or so. We're just going to practice converting the regions, and then tomorrow we'll integrate it once we've converted the region into easier bounds for us to work with, and then figuring out that extra little piece. What is that r or that rho squared sine phi? Like, what is that extra piece that we need to do? So today is just going to be converting between regions. So first one, I have this original region that's an ellipsoid, not an ellipsoid, an ellipse, excuse me. It's okay to work with, not great. I'd much rather have something like a straight circle or rectangles, whatever. So I want to convert this original region into a new region using the transformation they gave us. Now, a lot of the times I'm going to be giving you the transformation because it kind of goes out of nowhere if you have no idea where to start. But let's convert this into a new region. So we're taking our x's and y's and we're going to change it into u's and v's. Go ahead. While you're doing it, I'm going to kind of be doing it for Cooper. So Cooper, if you can do this yourself, great. If not, we've got the transformation right here. What should we do? Well, what should we do? Plug it in and see what happens, right? So when you plug it in, we get some nice ones. Which is a nice circle that we see. So we can see that we get u squared plus v squared equals 4, right? So we've made ourselves a circle. We know how to deal with circles. We could change it into cylindrical coordinates and we can go from there. Again, I'm just converting regions right now. So what I've seen is that I can take an ellipsoid and I can convert it into a circle, again, making it easier for us to deal with. So that's great. Another new region. Let's find the new region. If the original region is bounded by y equals negative x plus 4, y equals x plus 1, y equals x over 3 minus 4/3. My transformation that I'm going to use, x equals 1/2 u plus v, y equals 1/2 u minus v. Okay, so convert this region. I'm going to draw the original one, and then we'll convert it into one that's a little bit nicer, I guess. So the original region R, all right, let's look at what this graph looks like. positive 4 down to, so there's my y equals negative x plus 4, x plus 1, and then negative 4/3 x going up 1/3. It ends up cutting through this point right here. And we get that y equals x thirds minus 4/3. Okay? So my original region is this piece right here. Not great, not terrible. Triangle. I definitely see, regardless of the way I'm cutting it, if I cut it horizontally, I'm gonna have to do 2 separate regions, right? Because I'm gonna have the upper piece and the lower piece. If I cut it vertically, again, I'm gonna have 2 pieces. So it's not that you couldn't do this region, but can we make it into an easier region where maybe I only have to do one integral or one integration instead of doing multiple ones? It's a terrible looking triangle now that I look at it, but that's okay. So what I like to do is just start with one of these sides. Let's convert one of the sides first, and it doesn't really matter. I just start with this one here, and I called it R1. And again, this is just my notation for it. You don't have to use this notation, but it helps me kind of figure out where I'm going. So let's convert this first line segment, which is y equals negative x plus 4. This particular bit, before we get into the integrating part, is a very much an algebra topic. It's kind of, I don't know, I think it's kind of nice. So we're converting this first line into a new one. So let's plug it in just like we were doing before. I'm going to call this S1 to show that correlation between the two. And really everywhere I see a y, I get to plug in, and everywhere I see an x, I get to plug in. So 1/2 u minus v equals negative 1/2 u plus v plus 4, and then let's simplify it, okay? Things will cancel out. Cool, those will cancel, the v's will cancel, and I'm left with u equals 4, correct? That's what you got? So ideally what we're thinking of when we're doing this is I just took this diagonal line and I changed it into a horizontal line, or a vertical line actually. That one's a vertical line. So I'm erasing over here because I'm going to start sketching this new region that's going to help us. So there's my original one right here. And my new picture, going over here onto this side, where I have u's and v's. Now I can go to u equals 4, and I have this new line segment for S1, or not a new line segment, new one. So that's going to help me a little bit. I'm going to do it now for the other 2 sections. So go ahead and finish those other 2 if you haven't already done so. I'm going to go quickly. I'm not even going to show it. So if you guys have already done it, that's great. R2 for me was this diagonal line. So y equals x plus 1. And when I converted it, I get v equals negative 1. Does that sound about right? Good. And then my last section, R3, was y equals x thirds minus 4 thirds. So my new section, I got to be this one, not as nice, but v equals 1/2 u plus 2. Yes? So again, let's just compare the regions here. There is my S1, that was just u equals 4. V equals negative 1 is down here. So that's my S2. And then 1/2 u plus 2. It's going to give you something like this, okay? And obviously my picture, that's not so good because that looks like it's going through the origin. But what I'm getting is now this particular region right here. Better graphs, check out my notes online when I put them in after this block. But you notice now how we took this particular region, that if we wanted to cut, I went from R2 to R3, and then from R1 to R3, just if we went that way. and I made it so it was just S3 minus S2. That's again what we're doing. We're trying to make simpler regions by doing some problems like this. I got one more. So this one is actually going backwards. Again, just getting us comfortable with this. You're not gonna ever do this. You're not gonna take the easy one and make it hard, just so we are aware. But let's just convert. So our last example for today, given a transformation that says x equals u squared minus v squared, y equals 2uv, find the original region. If the new region, we'll call it S, are your points u and v such that u is between 0 and 1, v is between 0 and 1.
What are the numbers, Mason? What do they mean? You substitute. No, I was kidding.
So u and v right here. So you go from 0 to 1, go from 0 to 1. This is your nice new region for S, okay? That's your good region. Again, we would never do this, go backwards to the original one, but it's good for us to practice going through these regions. So this is the new one. I want to figure out the original ugly looking thing, okay?
Whack.
So figure out what your S1, S2, S3, S4 are, and figure out the equations for those lines. You know them.
This is whack.
Why is this whack?
Whack.
What's the equation for S1? U equals 1.
Oh. S1?
That was just this side length, this equation.
Would it be V equals 1?
No, U is the, no, U equals 1.
No,
And then-
you said, no, you're wrong.
V
It's
equals
one.
1.
Please.
S2 is gonna be V equals 1.
Oh, okay.
S3 and S4.
That's why I'm wrong.
Horizontal lines go with those.
I was gonna say, wait, shouldn't V be the one we're talking about, but we are just talking about V.
They're all between
Listen,
0.
shut
Yeah.
your hands up. I'm gonna do your mom, bro. Good luck.
So again, we're just trying to kind of convert this here.
That is true. Just gotta put it as a move. Big jump.
So what do you think we should do?
I don't know. I think I should be good.
Factor.
So U equals V.
On this first one, you mean?
Yeah. U equals V equals negative.
Let's plug it in and see what happens, right? So when we plug this guy in, where I see a U, I get to put in a 1. So x equals 1 minus v squared. I'm obviously not done yet, but there's my start. And then for my y equals 2v.
Or not to be.
That's the question.
That is truly the question.
What are you gonna do?
Give up.
Please don't honestly give up. What are you gonna do?
Give up. It x goes
Substitute.
X goes from 1 to 0.
Yeah.
Or you can substitute.
What are you gonna substitute?
Y over
Your
2.
mom.
Y over, v equals y over 2. You see this right here,
Okay, this marker is gone. So
right? So let's plug it into this and see what happens.
4.
I hate markers.
Maybe markers eaten.
Bro, markers are inanimate objects. They don't have feelings.
That's what you think.
Toy Story proves otherwise.
Toy Story or movie, not a documentary.
How do you?
Think again.
Ooh, and it was squared, so silly me.
Yeah.
Squared, right?
Yeah.
So you notice here, if we were actually paying attention, we get some type of sideways parabola, which we'll finish here in a second. Again, you try to work through these other ones. We're just trying to solve systems. This is why we usually don't go backwards. We would go the normal way, which is a little bit easier. Hey, what's up?
Hi. This is a small class. I was wondering if I could interview someone for your book, Joe specifically.
Go, Joe. Goodbye, Joe.
Come on, Joe.
You're stealing 1/4 of our class, or 1/5 of our class. Boy, yeah.
There's
that's-
usually another
technically,
person.
Cooper's not here.
Cooper's not here. Damn it, Cooper. Probably shouldn't say
You
that.
said
on the
25%
video.
of the class stolen from us, guys.
It's okay. We'll survive.
But it was like one of the top 2. No offense, Michael, but we're really not breaking any boundaries. I think we're really smart and square.
No, I understand.
Still, I don't know why you're talking. Okay, u equals 0. So in this case, we get x equals negative v squared. We get y equals 0.
I'd say. I just keep Googling answers and it just keeps working, man.
What are we gonna do here? So the first two were kind of nice because we could just plug in and get some parabolas in here, but what are we gonna do for these bottom two? I did my substitution. I put in u equals 0. I got x equals negative v squared.
I'm able to ask someone else.
Anyone want to?
I can do it.
Go quickly.
Michael, please.
What is it?
I can't answer your question, but Joe can't answer my
Why
question.
can't you answer questions?
Because you have to say it specifically.
Anyways, go. Come on, we're in the class.
I'm sorry for interrupting.
No, it's okay for you. What would you do?
Would you take one of the V's you got up above? The V you got up above, so y over 2, could you put that in?
Don't worry about going above. Just worry about this piece right here. We know x is negative v squared, y is gonna be 0. Use that second fact. That's why I wrote it down everywhere, even though like we didn't even use it in these first 2 bits, though we could once we get far enough. But in this case, we know y is 0, that's nice. If x equals negative v squared, let's range it from 0 to 1. What is that gonna look like? X is gonna be,
Between.
What was the question?
It was very hard.
Who to call if you need mental health?
I just need a photo and then I'm out of here.
Joe doesn't have a mental health.
0 to negative.
That is a true fact.
so there's a point to that point right there. Sorry, Cooper, since they are now just distracting from everybody. So we get a line segment, Hannah?
Yeah, Michael, learn.
And then we're gonna do the same thing down here.
Thank you.
It's my word, yeah.
We're gonna have V.
Tell everyone to say hi.
Okay, shut up.
Guys, you're being so rude. Stop. Because when you don't know how to do this, I'm not gonna feel bad about it. What does your y become?
0.
Y is still 0. Plug it in, what do you get? You get 0, 0 to 1, 0.
Yeah. That's what I meant.
So now when you go to plot this, again, here was your original, was this nice square. The original bit, have enough room. I have enough room. Okay? You're getting a line segment from 0 to 1. That was S4, not S4, R4. You have R3 that was from negative 1 to 0, so you just have this line piece down here. Isn't these 2 pieces gonna be sideways parabolas, right? So one's gonna kinda go this way, one's gonna kinda go that way, right? I'm hoping I'm drawing that correctly, I'm kind of rushing.
I feel like that's pretty much correct.
Where's my picture? Yep, and it like intersects here at 0, 2. So you see you have like this parabolic shape that maybe you don't want to deal with. So I can convert this parabolic shape into a square. Pretty nice. It's an easier way for us to integrate it, let's put it that way. We're taking this piece here that is, you know, a squared, so if we're bounding it, we have to have v squared or was it v squared in there, and we're converting it into 0 to 1, 0 to 1, that's nice.
Okay, so then the answer we get, like if we were to do the integration, the answer we get would be the exact same as if we didn't take?
Yes, but your bounds are gonna be like a lot uglier in this, so if I'm bounding, again, I don't know what my function is at this point, but when I'm bounding this, I'm gonna go from -1 to 1, do I wanna go that way? No, I wanna do this kind of integrate, I wanna cut this way. So I'm gonna go from 0 to 2, and I'm gonna go from, I think, I'm rushing right now, so bear with me if this is backwards.
And so like, I see why that would be the balance, and why it would be easier to convert, I'm just wondering like when, I guess this is more of a question for tomorrow, when we integrate it, would it be the exact same?
So yes, if you did this and you had your initial piece, and you do this thing with that extra little Jacobian piece that we'll talk about tomorrow, you're gonna get the same answer. So this piece equals the integral here from 0 to 1, 0 to 1. My function now converted into u's and v's. There is one little piece here that we don't know yet until tomorrow. And if we add that, it's DAs, I keep doing that. But if we add that piece, those two things are gonna be the same. So that's what we're gonna be looking at tomorrow doing, okay? So I'm pretty sure, I can't guarantee it, I have to double check my notes, but I'm always gonna give you the transformations, because if I don't give you the transformations, I don't know how you know to pull this out of your hat. Like, that's just one of those things I don't know how much we're gonna be good with. But once you get it, it's a lot of algebra plugging in to kind of get your answers. So here's how we do regions. Tomorrow, let's integrate it. So we'll learn our little Jacobian piece. Again, why did we get R when we did cylindrical? Why did we get rho squared sine phi when we did spherical? We'll see it tomorrow, okay? All right, bye, Cooper. We'll see you tomorrow.